Dear students, how are you all? Welcome to our online class. We are studying a chapter. It's called Reflection of Light. We are in the middle of the chapter. I hope you will understood all the aspects of this chapter. Today we'll start from spherical mirror. We all have seen ordinary plain mirror, but many of us not have seen a real spherical mirror. But the main concept of spherical mirror can be seen in new shiny spoon. Spherical mirror are of two types, concave and convex. We can make concave and convex mirror by cutting a portion of a hollow sphere and coating it in one surface, inside or outside surface, with an aluminum or silver layer. Whether the spherical mirror will be convex or concave depends on which surface is coated with silver or aluminum. There's two types: convex, the part of a sphere, and inner part is coated with aluminum or silver, and outer part is shiny. This is convex mirror. Concave mirror, this outer part is coated with silver or aluminum, and inner part is shiny. This is concave mirror. Okay. An actual convex mirror is a part of a real sphere. Let the radius of the sphere be r. A part of is being made to provide for reflection is higher convex side. So I have to draw. So inner part is coated. So reflection occurs in outer part. Beam of light parallel to each other. So they reflect and they come from a point. This is called diverging rays. It's for convex mirror. Convex mirror creates diverging rays. Okay. True that F is equal to R by. So this is a very important proof. So to prove that, I have to draw a figure. For convex, concave, I can draw anything. I can prove it from any aspects of mirror. Okay. Now I'm going for the convex mirror. Okay. This is my axis. A parallel ray of light X A is the says goes from focus P and this is C. Point is Y. So there are two angles, theta 1, theta 2. Now this is R radius and this is F focal length. Okay, we have to find the relation between them. FO FO is equal to FY because triangle OFY Y angle FOY is equal to angle OYF. FOY FOY is equal to OYF. This one. Okay. As FOY is equal to theta 1 and FYO is equal to theta 2. R is equal to R. And FY is have to be equal to Fx. They are very small and closer to each other. And this is true for most so FO equal to FY is equal to Fx is equal to R by 2. So F is equal to R by 2 proved. Now or convex mirror. Okay, now I gonna draw a diagram and or figure. Then I will make a image from the figure. To see the figure very attentively, and you might understood how I drew the figure. Now, first draw a convex mirror. Then make an axis on it. Now you better take your scale. Okay, then mark it. It is half of pencil curvature. So if this is focus, this is center of curvature. This is a large object A, B. First, a parallel ray of light comes from A point and hits on this mirror, and it goes figure from the focus. Then it goes through center of curvature. That direction. Third ray comes from the toe and hits and reflects on the same position on opposite direction, like principal axis. So they meet on this point. This is the image of AB. It's very simple. We can bring three rays of light and the reflection, and we can get a image of any object. Okay. So A prime B prime is the image of A B. It is clear that actually no light is come from XY. It just appears that the image is here. Hence, it is a virtual image from inside the mirror. So it's a virtual image. Comparing with the image formed by a plane mirror, we can see that the position of the image will be between the focus and the pole, and focus and the pole. So the mirror, further the object is, the closer the image of the focus. The image is virtual, the image is upright, the image is small, and the further the object moves from the mirror, the smaller the image becomes. That is the consequence for convex mirror. Now come to concave mirror. The inside of a shiny spoon is an example of concave mirror. Those of who have looked at the side of a spoon must have noticed that the image is small and the in and the interesting thing is that the image is inverted. You can take your finger very close to the spoon and notice that the finger is upright. Now move your finger slowly away from the spoon. Notice that your finger is starting to look bigger. You are able to produce an image in the plane mirror or convex mirror, but never image larger than the real size is the object. This is the first time we are seeing larger image. If you are moving your finger away slowly, then you will notice that one point that the image gets inverted no matter where you are while moving away from the point. It will always remain inverted. We were never able to create inverted image using plane mirror or convex mirror. This is the first time we are doing so. So you can see that the outside part of a spoon works as convex mirror and the inside part works as a concave mirror. A real concave mirror is actually a part of a sphere. In this case of a convex mirror, light were reflected from the outer convex shape, and in the case of concave mirror, light will reflect from the inside concave shape. If parallel rays are incident on a concave mirror, the light ray will converge at a point after reflection. This gets a converging lens ray of light, and this is our concave mirror. This is P. This is our center of curvature. Half is F. So ray of light parallel to each other. Sorry, parallel to each other. After reflection, they meet on principal focus. This creates a converging rays of light. You can understand that this point of the focus point of the concave mirror and the distance from the pole to the point of known as the focal length, focal distance. Light ray don't have any option to stopping, so after concave concaving at a point they will travel straight forward and it will look like light is diverging from the point. Therefore, before reaching the focal point and the ray are converging, and after reaching the focal point the rays are diverging. Okay, this is the way we draw concave mirror. Okay, there's a question. If we imagine a plane mirror as a spherical concave mirror, what will be the focal distance? The answer is infinite. We got the same answer in the case of convex mirror, which means that when the focal distance increases to infinite, then both concave and convex mirrors turns into plane mirror. The focal distance of the half of the radius is concave mirror as in a convex mirror. The focal length is half of radius curvature is both happens for convex and concave mirror. Okay, so from this class you have understood the types of mirror and then spherical mirror types and their core issues, and then we drew an image construct image for convex mirror. In next class, we will do it for concave mirrors. Okay. Thanks for watching the video. Be safe, Allah.